Good morning to all of you. So in previous session we had discussed rational Z transform where we have seen the definition of zeros and poles, right? So in today's session we will go through one example where we will be trying to plot or represent the x of z by using pole zero plot. Okay. So here is the example. Here we have to determine the pole zero plot for the signal x of n is equals to a to the power n u of n. Okay, so in this case initially we'll determine the z transform. Okay, so the z transform for x of n. Okay, so initially identify z transform of x of n. Okay, so the formula for z transform of x of n will be x of z is equals to summation n is equals to minus infinity to infinity x of n into z to the power minus n. Okay, so the given x of n is a to the power n u of n, right? So here summation n is equals to minus infinity to infinity. In place of x of n you can substitute a to the power n u of n. So a to the power n u of n multiplied by z to the power minus n. Okay, so as we know that this u of n is the elementary discrete time signal, and we can modify these limits of summation as n is equals to 0 to infinity. For negative values of n, u of n is 0, right? So for negative values of n, u of n is 0. So instead of including those negative values, you can start this limit from 0 to infinity, and for these values for n greater than or equals to 0, u of n is 1. So you can simply write a to the power n, u of n is 1 here, a to the power n into z to the power minus n. So that is x of z. Okay, so again I will rewrite this one here. So x of z is equals to summation n is equals to 0 to infinity, what is that, a to the power n z to the power minus n is there, right? A to the power n z to the power minus n. So I can take this n common, so here it will be n is equals to 0 to infinity a z inverse raised to the power n, and as per this infinite geometric series n is equals to 0 to infinity a to the power n is equals to, you can represent a 1 upon 1 minus a, provided that mod a should be less than 1. So here you can write it as x of z is equals to 1 upon 1 minus a z inverse, provided mod a z inverse should be less than 1. So that means the ROC will be mod z greater than a, right? So in this case ROC is mod z greater than a. Here we can again rewrite this x of z as uh, this is nothing but 1 upon 1 minus a by z is there. So I can write z minus a upon z. I can say z in numerator, so it will be z upon z minus a. Right? So we are represented it in rational form, as well as we have avoided the negative powers of z. Okay, these two expressions are same. Okay, 1 upon 1 minus a z inverse is nothing but z upon z minus a. So this is the required what z transform of the given discrete time signal x of n, and from this z transform we'll try to draw the pole zero plot, right? So for this x of z, is x of z, this x of z has, so if I'm substituting z is equals to 0, so the x of z will be 0, so it has 0 at z is equals to 0. And if I'm substituting z is equals to a, so it will be a minus a will be 0, so 1 upon 0 will be infinity. So it will have it will have pole at z is equals to a. Okay, so thus x of z has 1 0 at z is equals to 0. Okay, so if I'm substituting z is equals to 0, so this will be 0, right? And one pole. Okay, it has one pole at z is equals to small a. If I'm substituting z is equals to small a here, so a minus a will be 0, 1 upon 0 will be infinity, right? So it has one 0 at z is equals to 0 and one pole at z is equals to a, right? So these values can be represented on the pole 0 plot. For that purpose, again, you will draw this graph. You will draw this graph. On x-axis, you will draw the real values of z, okay, and on y-axis you can draw the imaginary values of z, right? So here the ROC mod z is greater than a, so you will draw one circle. What you have to draw? One circle with radius small a, okay. So I have drawn one circle with radius small a and ROC is exterior to that circle. So here you can represent the ROC. We have seen already these things, how to plot the ROC. So this will be the ROC which is greater than a, okay. For all values of z greater than a, the x of z will be finite, okay. So this will be what? ROC. Now on this ROC plot you can represent the poles and zeros, okay. So 0 is at z is equals to 0, so zeros are represented by using circles. So here you will represent 0 by using a circle, right? Because at the center value of z is 0, so 0 will be present at this circle. So this is nothing but what? Your 0. And similarly you can, so this will be 0 at z is equals to 0, right, indicated by circle. And similarly you can indicate the pole at z is equals to a, so the value a is present on this circle, anywhere on this circle, so that will be represented by using a cross sign, okay. So this value here is a, right? So this radius is a and this value on this circle is a, and this pole is represented by using a cross sign, right? So this indicates what? A pole 0 plot for the signal x of n a to the power n u of n, okay. So this figure indicates the pole 0 plot for the signal x of n is equals to, the given signal is a to the power n u of n, okay. A to the power n u of n, right? So this is how you can obtain the pole 0 plot. Initially you have to identify the values of 0 and pole from the obtained z transform by substituting the values of z in the z transform. So for the z transform, 0 is at z is equals to 0 and pole is at z is equals to a. So if I'm substituting a here, so a minus a will be 0, 1 upon 0 will be infinity, right? So according to that you can represent the values of 0 and values of pole on this ROC plot. So that will be now referred as what? Pole 0 plot, okay. This will be referred as pole 0 plot here, right? So in this session we have seen one example. We obtained the z transform of the given discrete time signal x of n. From that z transform we obtained the values of 0 and pole, and we indicated those poles and 0 values on the pole 0 plot. So in next session we will be discussing the pole location and time domain behavior of different signal, discrete time signal or causal signal. That topic we'll discuss in the next session. Thank you for joining this session.